Hi everyone. So last class we talked about solving for the missing side of a triangle. This class we're going to talk about solving for a missing angle. So example 1 here, for the right triangle ABC shown below, what is the sine of angle B? So let's think back to our SOHCAHTOA. And we know that sine here, our S, is the one that we're looking for because our problem is asking for the sine of angle B. So sine means opposite over hypotenuse. So our sine of B here is going to be our opposite side over our hypotenuse. So our opposite side of angle B, remember back to our definition of opposite, it means across from. So opposite is 12. Our hypotenuse is the longest side of our triangle. It's also the side opposite that right angle. So here it's going to be 20. So there is our ratio for sine of B. But this problem wants to know, what is the measure of angle B in degrees? So just knowing that ratio, how are we going to find that measure of angle B? Well, to compute the measure of an angle, when you know its sine, cosine, or tangent ratio, you use the inverse. And here's the notation for inverse for sine, cosine, and tangent. So here we do know that ratio. We know that ratio right here. Sine of B equals 12 over 20. So I'm going to take the inverse sine of both sides. I have to do it to both sides because remember, when I have an equation, I have to do the same thing to both sides so I can keep it balanced. So once I have the inverse sine of both sides, the inverse sine of sine cancels out, so I just get B. And then in my calculator, I'm going to put in the inverse sine of 12 over 20. How am I going to do that? You do your second button, so that blue button at the top, and then the sine button here. That'll give me inverse sine. Then I enter in my 12 divided by 20. I get out some big long number that I'm just going to round to the tens place, so 36.9. So my B is going to equal 36.9 degrees. I could also round it to the nearest degree, so I could also say B is equal to 37 degrees. It depends on what the question's asking for you. It'll tell you what number to round it to. So let's do another example here. So we're going to find the measure of theta and round to the nearest degree. So it doesn't tell us, in the example up here, it said, what is the sine of angle B? It doesn't tell us which trig relationship we're going to be using here. So we have to figure that out ourselves. So we have to decide out of SOHCAHTOA which one we're going to be using. So let's take a look at these side relationships to our angle theta. So here, how does 13, what is the relationship between 13 and our angle theta? That's going to be an adjacent side because it's next to it. That's the definition of adjacent. How does side 4 relate to our angle theta? It's going to be opposite because it's across from our angle theta. So which one of these trig relationships uses the adjacent side and the opposite side? That's going to be our tangent. So tangent of our angle theta is going to be opposite over adjacent, and that's going to be 4 over 13, or opposite over our adjacent here. So we have our tan of theta equals 4 over 13, and to find the measure of that angle theta, we need to take the inverse tangent. Remember up here, when we have the measure of an angle, or to compute the measure of an angle when you know its sine, cosine, or tangent ratio, here we do know that tangent ratio, we use the inverse. So let's take the inverse of both sides of our equation. So inverse tan of this side and inverse tan of the right side as well. So when you take the inverse tangent of the tangent, you just end up with theta. And then when you take the inverse tangent of 4 over 13, you have to do it in your calculator. So we're going to go second and then hit that tangent button. That'll give us the inverse tangent. And then we're going to put in 4 over 13. So that'll get out 17 degrees if we're rounding to the nearest degree like the question asked here. So my theta here is going to be 17 degrees. And then our example 2, part B here, we have to again find which ratio we're going to be working with. So we're going to think, is it going to be our SO, our CA, or our TOA, our sine, our cosine, or our tangent? So let's take a look at our angle theta and see what relationship these sides have to it. So my 4.4 here is at adjacent, opposite, or hypotenuse. It's going to be adjacent because it's directly next to my angle theta. My 11, is that going to be adjacent, opposite, or hypotenuse? This one is going to be my hypotenuse. It's across from my right angle, and it's also the longest side of my triangle. So which of my SO, CA, or TOA uses the adjacent and the hypotenuse? It's going to be my cosine. So cosine of theta is adjacent over hypotenuse. My adjacent here is 4.4 and my hypotenuse is 11. So my cosine of theta is going to equal 4.4 over 11. I want to find the measure of my theta, so I'm going to take the inverse cosine of both sides. When I take the inverse cosine of theta, I am just left with theta. When I take the inverse cosine of 4.4 over 11, let's find out what we get. So second cosine, that's going to give me that inverse cosine. 4.4 over 11. It's going to give me 66.4218. It tells us to measure round to the nearest degree. So 66 degrees is what we're going to go with for this one.